Hey, thank you. Good afternoon. It's lovely to be back. Last time I was at TUG conference was in Vancouver in 1999, so 15-year gap, and I'm back. I'm in a new job since then. I was a grad student at that time, and after that I went and taught in a secondary school, high schools for the Americans amongst us, in England for about 10 years. And now, in the last 6 months, I moved to Cambridge, and I'm working on a project in Cambridge developing resources to be used in the classroom for 11th and 12th grade students, that's 16 to 18-year-olds. I'm working on the mathematical side, but I do have a technical bent, and if my boss lets me, I do bits of technical stuff. Anyway, so I want to talk about some mathematical jigsaws this afternoon. So using Beamer, because I like tech. So 3 sections: motivation, what is it all about, why we're doing it. CMEP is the project I'm working with, so I'll say a little bit about why I'm doing this project at all. Then a bit about what the software is and how I've done it, and then the last bit is me asking you guys for help because I'm completely stuck. So let me tell you about where we're at. Whoops. Okay, so what's a mathematical jigsaw? It's an activity used in maths classrooms for a variety of purposes. If we want to do routine practice of something, some skill, you can give students a textbook exercise, or you can get them into a computer and do lots of routine exercises to practice something. Can get a little boring, and lots of students will go, I'm bored, I've done 3 already, do I have to do more? So this is one way we can find of making things a little more enjoyable to do practice. It can involve logical reasoning, it can involve all sorts of other aspects as well. And within the category of things we call mathematical jigsaws, there are also card sorts where you have to put things into order. Now, this may not make very much sense, so I thought, let's actually try some before I speak anymore. So on your tables, you'll find there are a couple of envelopes at the table. I thought there would be enough for like 1 between 3, but the room layout has meant that there are a few short. So one table only has 1 envelope. The table at the back has 1 envelope. There, lots of people sitting where I was. No, okay. So there should be at least 1 envelope per table. And the table where I was sitting, there are none. So if you move to the table behind you, there are 3 paper-clipped bunches of things in there. There's dark blue triangles. That's a jigsaw puzzle. The sides match if the question matches the answer. So if there's a question 3 plus 2, then that would match a 5. A question mark on an edge means that there is no answer given. You've got to figure out the answer. But that's hard because it's a jigsaw puzzle, so you don't even know which question it goes with. But by the time you've done everything else, you'll figure out which question it goes with. And to make it even harder still, the outer edges of this puzzle is going to make a big hexagon. The outer edges have got questions or answers which don't match anything. I tried to make the questions not too difficult to give you a sense of what the puzzle's about without doing your heads in on the mathematics. That's not the purpose of the session. The pale blue one is a card sort, a very, very famous result that the square root of 2 is irrational. And all you have to do is put them in order to create an argument. So rather than expecting students to have to prove it themselves, I've given you the proof, you just have to figure out the order. And the third one is the follow me cards, which is about practicing, I don't know what it's called in various countries, BIDMAS, BODMAS, the order of operations, multiplication, division you do before addition and subtraction. So you'd give them out to a group, and one person would read, the second half says, or it goes, I have 5, who has 3 plus 2 times 4? And people look on their cards like, okay, oh, I've got 11. Okay, so I've got a card which says, I've got 11, who has, and it continues around. Or you can lay it out as a series of dominoes. So that's the yellow cards. Would you like 5, 10 minutes to have a go at them? Go for it.
Which ones do you want? No, these are all ours. And then, of course, Square root of 49. 9 to the 9 to the 9. We've got a 9 to the 18. Big guy, no, still 28. 5 is divided by 2. That's probably an outside piece.
Hey, Julia.
Yeah.
You just do left to right, there's no precedence.
Again, it's the precedence multiplication division comes before addition and subtraction.
There's another 3 type deal.
So the way
Give those question mark. It's 9 to the 9 times 9 to the 9. We've got a 5 to the 6. But 81. Powers of 3. 3 to the 6 divided by 3 to the 9. 2 cubed divided by the square root of 6. There we go. All right, so we've all right. So there we go. Now we've got 3 cubed.
I messed up apparently on the yellow cards. I have 21, should say I have 19. And that was not a deliberate error. Oh.
We had some powers of 5 here somewhere.
You want to anyone? What is it? I was just wondering whether or not he's right.
Yeah, that's right.
Yeah, powers of 5.
You're my guinea pigs, right?
Yeah.
I've got a 4 to the 8, 4 to the 4th times 4. All right.
Very nice PDF render, but very nice one. Find a reference. Yes, people say that.
About 2 minutes, then we'll continue the talk. Okay, let me pause you there. I won't take the cards away from you, so if you want to continue with them during my talk, if you're a bit bored, I won't be offended. Let me give you answers to some of them, but not all of them. For the Jigsaw, the dark blue one, at the end, if you would like a solution, I have printed solutions, so you can take solutions. You may have noticed there are numbers in the centers of the cards with circles around them, little numbers. So when you're coming around and checking solutions, the solutions have the same numbers printed, and so it's much, much easier to say, well, I've got card whatever next to card whatever next to card whatever, and check them like that, and try and check all of the numbers on the cards. One person pointed out to me that obviously this is not unique to mathematics. It does not have to be maths on these cards. It could be any content. I'm a math teacher. I'm creating maths, math. I'm in the States now. I'm creating math, but it could be any content. The card sort, pale blue, the correct sequence is card number 2, followed by 5, followed by 6, followed by 7, followed by 9, followed by 3, followed by 8, followed by 4, followed by 1. And the following cards, dominoes, I haven't bothered to print out the answers. Okay. Except that 21 should be 19. I will show you afterwards how I'm going to correct that. Yes, I should do that. Okay, but that's just, okay. So okay. It will be fine. Okay, so what already exists? I didn't come up with the idea of these jigsaws. They already existed them, and they've been used in classrooms in the UK for a good few years now. There's a piece of software called Formulator Tarsia. It's created by Hermitech Laboratory. It's free as in beer. It's not open source, but it's a Windows-only, MathML-based graphical front end. You edit it using a graphical front end, and it creates all these fantastic jigsaws. Very popular. You can download resources that people have created, jigsaws people have already created. I'm working for this project, the Cambridge Mathematics Education Project. We're creating rich, engaging, coherent mathematics resources for 16 to 18-year-olds, trying to create things that are more engaging than just textbook exercises. We're in the development phase of the project. The public website is going to be launched, hopefully, in early 2015. It's going to be open access. Anyone can access it. It's going to be almost open source. It's some open government license, which is a bit like, I can't remember the details, but anyone will, internationally will be able to access it. But one of the things we're going to include is card sorts and puzzles and matching things and group these cards into so forth. So we wanted to create jigsaws that are actually easy to print out and nice. One of the problems with Tarsia for our use is that it's Windows-based, and all of the CMEP developers are using either Mac or, in my case, Linux. I prefer the quality of TeX output to the quality of Tarsia output. It just looks nicer. There's more flexibility and control with TeX. If I want to include something new, a new symbol, if I want to create something strange or whatever, I can do it. The Tarsia content, once you've created your jigsaw or your puzzle, if you decide you've created like triangles like this and you want to turn it into a jigsaw puzzle, there's no easy way to extract the data and import it into a new format. So I'd far prefer something that's text-based. Tarsia is semi-WYSIWYG, and that way it's a graphical front end, so makes inputting harder. You can't use text editor, you have to use mouse keys or click things to move around, and you can't see everything in one go that easily. Or if you can see everything in one go, then you can't edit it. You have to go back to an editing page. It's awkward. So the other requirement for CMEP is because it's also going to appear on the web, we'd like these puzzles to appear not just in printable format, but also on a web page. So the technical designer of the project has decided to use Markdown as the basic format. So we type everything in Markdown, and then he turns it using his software, using Pandoc primarily, into either HTML for a web page or into PDF. Very nice. So that led me to say, well, actually, I want to create these jigsaws in something which can produce beautiful printout using TeX or LaTeX, and also produce some Markdown output. So those are our design goals. Easy to input content. Flexibility to have different layouts, fonts, etc. should we wish it. Flexibility to easily change the format of the puzzle. If I do design it as something as a dominoes that follow me cards, and I want to turn it into a jigsaw, like the blue triangles, I don't want to have to retype all of that stuff. How painful would that be? So for that reason, all of the developers on the team are used to using a text editor, so text-based input would be fantastic. Our team are happy using LaTeX. They're mostly non-technical, so I can't assume they can do much more than use LaTeX and Markdown. And I want it that they can basically push a button or run one command line script to go ding and the jigsaw comes out. I don't want them to have to faff with all sorts of technical buttons, like one push thing. My ideal would be that it's operating system agnostic, that it should run equally well both on Linux and Mac. If I can get it to run on Windows as well, even better. It's got to be easy to install and use for my team. I don't want to have to be actively maintaining it. I've got my job that I'm being paid for is to create mathematical puzzles and problems and things for use in the classroom, not to be writing software. I get told if I spend too much time not doing what I'm meant to be doing. For ease of installation, I want a minimum of non-standard dependencies. So simple things that I can install it on a Mac or a Linux system easily. Again, so easy to maintain and extend. If one of my colleagues says, I'd like to do this, I can do it. The data input file, I'll show you one example of data input file. I'm using YAML for that. If you're not familiar with YAML, it's a bit like JSON. It's a very simple text-based structured document with almost no markup. Very, very, very simple. The markup doesn't get in the way of reading it. You can see the text very easily. I'll show you one in a moment. I have LaTeX template files. So these triangles that you see, and in fact all of the puzzles you see in front of you, were created with TeX templates. So I don't know how to pronounce TeX. If anyone knows, feel free to correct me. Tixi? Okay, so I use Tixi. So I've created a template which you put, my software puts the content into the template and runs LaTeX or LaTeX or whatever it might be over it, and you create a printable PDF. I've also got some data structure template files. So somehow between the data input, which says I've got a pair, a question and an answer. So on the triangle puzzle, on the jigsaw puzzle, the question might be 3 cubed times 3 cubed. The answer is 3 to the power of 6. The input file will say this is a pair of question and answer. My YAML, my Tixi template will say here's a pair of matching sides. Somehow I have to keep track of where the matching sides are. So I also have a structure template file which keeps that information. So this triangle contains question 1, question 3, and question 7, and is rotated by 90 degrees. This one contains... So a technical file, once it's written once, it should never need tweaking again. The software that takes the input YAML and creates the output and runs LaTeX over it is written in Python. And it just pulls the information, might randomize things, mixes things up according to whatever the instructions are, and puts it in the template, then runs LaTeX. Seems to work. Fantastic. I'm regarding the software for a critical reason, which I'll explain in a minute or two, as alpha, not yet beta. It's not yet generally releasable. You can download it, I'll show you where it is, but there's one big hole. So I'm going to show you an example of what data my colleagues would have to type with. It has 3 parts to it. There's the title and what type of puzzle it is. There's the layout, if there's any, how we'll see it in a moment, and the content. So the title says, okay, it's YAML, so hash in YAML is a comment. So the title is proving that square root of 2 is irrational. It's a card sort. So if I use my mouse to point so that it gets tracked. It's a card sort, which means it's going to come out as a series of cards. The title, which gets printed on when you produce the PDF, it says title at the top, but then my undergraduate students help me by cutting it out so you can't see the title. Hence, you don't have to sit here for an hour with pairs of scissors cutting. But my students do love it. I bring them a sheet which is uncut out, and they go, here's a bunch of scissors, here's a bunch of puzzles, go cut. They have such fun doing that. Anything to not be doing maths, right? But no, they're looking at the questions already as they're cutting. They're beginning to think about it, so it gives them a bit of time, a bit of breathing space and thinking space. And the group after them, they already have them cut out because I keep them from one session to the next. And there's a note which again could be printed on the top of the printable thing before it's cut out. So the notes in this one said sort cards into order to prove that square root of 2 is rational. Then there's a bit of boilerplate which you can tweak as appropriate. So the boilerplate says how big is this puzzle? So this is a sequence of cards. It's going to have 6 rows on a sheet and 1 column because this square root of 2 quite long statement, so I didn't want to have this cards. But if I wanted, say, 2 columns on a page, I could say columns is 2. We're going to give the sequence of cards in the correct order in a moment in the file, but we don't want... Whoa. Go back. There we go. But we don't want to give the students them printed out in the correct order because then there isn't really anything for them to do. They come to cut them out and go, oh, but it's already in the right order. We smarted out the teacher. So I said shuffle cards is true. So the cards will be shuffled, the order of the statements will be shuffled before they're printed. So statement number 1 will be, I can't remember what statement number 1 was, but it certainly wasn't the first statement in the correct answer. Does this puzzle require production of a solution? Yes. This is a puzzle where they've got to sort things, and therefore there is a correct solution. But another example was, here are a bunch of statements, sort them into 3 groups, those which are always true, those which are sometimes true, those which are never true. There's no inherent order to the questions or to the statements, therefore there's no point producing a solution. It wouldn't mean anything. So in that case, I'd say produce solution is false. Default text size, I could ask my colleagues to know the difference between footnote size and small and tiny and large and huge. I don't remember the order. I've looked it up, typed it out once. I hope never to have to look at it again for this purpose. So I've called the text sizes ranges from 0 to 9 or 0 to 8 or something. There's a title on every card, CMEP, square root of 2 is irrational, and the title size is much smaller, so it doesn't distract from the actual content of the card. Finally, for the layout, when I did this for our project, I wanted some sort of specialized output for Markdown, which contains divs and stuff, so it works well on our HTML thing. So I've created a template specifically, so I can override the default template and say it. Oh, yeah. And then the cards, literally just so all of that up to there was boilerplate, and now here's the actual content. I've done some ... at the end, but you can see you've literally just typed the content. The amount of layout here and the amount of formatting symbols is absolutely minimal. So you can type the content, push the button, and it goes. That's what I wanted. All of the effort is in writing the mathematics and deciding on, do I want a card sort, do I want a jigsaw? If it was pairs for the jigsaw, you have pairs, so it would be dash and then a square brackets, item number 1, comma, or question, comma, answer. Equally simple. Make sense? Okay, so I have a few minutes left. Let me tell you the other niceties. Oh, you've seen that you can number the cards. So this means that I can read out the answer to you. I can either read them out and text the answer goes like this. Suppose for a contradiction that square root of 2 is rational. The next card says this means that we can write square root of 2 equals a over b, blah, blah. Or I can just read out the answer. The answers go 7, 2, 1, 4, or whatever it might be. On the puzzle, you see that on the triangles, the red, dark blue triangles, there were a couple of where I put question marks. On the solution, those question marks have been replaced by the correct answers highlighted in yellow, so you can easily see where the missing ones were and check that you're right. Obviously, this could be rotated by various multiples of 60 degrees. But there is that facility which Tarsia didn't have, but I thought that would be really useful to have that ability to hide things. This can also handle images very, very easily. I'm using Markdown syntax for images because that's what my colleagues are used to using, and it turns out that it's much easier to translate Markdown into \include graphics with whatever parameters than to change \include graphics into something that Markdown will be happy with. Okay, now here's where I'm stuck and why it's alpha. I have no idea how to answer this question. This is not a Python module. This is a piece of Python. It's a Python script with a bunch of template files. I do want users to be able to create their own templates if they so wish to have specialized templates. Where do I store them on the different operating systems? There's some standard way of doing it and some standard way of teaching Python where to look for things. I don't want to reinvent the wheel if I don't have to. How do I create something that's installable on those different operating systems so that people can just download it and go bang and it works? I don't know the answer. And I want it to work identically on these different operating systems. So that's where I'm stuck. I'll come back to that in a second. I'll open the floor for any advice. What I still need to do once I've figured out that is I need to write some documentation so that somebody other than me can use it. I want to allow for some command line configuration. So, that's the other thing I'd like to know is if there's a standard configuration file that goes with this, where should it live on the different operating systems? And we could potentially create a graphical front end for it, but I'm not totally keen on that idea. And if you are interested in seeing where that software lives, I've got on GitHub at the moment. My GitHub name is Julian Gilbey, and it's the only project I've got on GitHub. It's called Jigsaw Generator. If you do have ideas and suggestions, feel free to email me. But I have 5 minutes, so if anyone has ideas, I'd be delighted to hear them. Yes?
Have you looked at Python's setup tools?
Does Python setup tools work for Python, even for that sort of...
It's for installing Python packages, and you can write scripts, and it has configuration. And
okay, and does that work even for Python programs as opposed to Python modules?
Yes.
Oh, fantastic. That is brilliant to know. Thank you. So I will look at setup tools. That's the obvious place I should have looked, right?
There's like 8 different ones for Python, so it's not that obvious.
Ah, okay, so setup tools. I will certainly look at that. Thank you. And any other suggestions? Okay, looks like setup tools is the way to go. If people, oh, yes.
Yeah, I like the way you're using the very, very simplest syntax that's possible. That's the Markdown is great, YAML is great. I don't know, I'm trying to work, I don't know if this is relevant or not. I've used a thing that I'm talking about more, it's called live code.
Right.
It's actually, if anyone remembers HyperCard.
Yes.
HyperCard was killed off by Steve Jobs. Yeah, no, you should share tears.
HyperCards were fantastic.
Yeah. Anyway, LiveCode is a superset of that, and it uses all of that. Somehow, I think there's something in there.
Okay.
It's completely platform independent. It runs on every machine, and if you want data, it can store it in the same way on every machine. And the programming language is HyperCard, which is the simplest. So somehow I feel that would fit into that.
Okay, thank you. I'll certainly go and look at LiveCode. So I've got LiveCode and setup tools. Thank you. And one thing I have to say, by the way, I'm really sorry. I'm not going to be here for the next 2 days. It's nothing to do with my talk. I'm here for Math Camp, and as 12 of my Math Campers joined us today, and it was just so fortuitous. Math Camp and Tug were in the same place at the same time. So I'm delighted to be here. Yes.
So, the question about
Please.
for you. So, do students find this compelling?
Yes, they really, really enjoy it. One of the things I sometimes have done in classes is once we've done a puzzle like this, and a puzzle like this could easily take half an hour or 40 minutes, give them a large sheet of paper, stick it up, we glue it onto the paper, and then we stick it up on the classroom wall so they can see the results of their work. So it's not lost. That's one thing. Another thing some people have done is they get students to copy the questions and answers into their books. I'm not sure I'd want to do that personally. All the effort is in doing the puzzle, but they find the idea of actually physically moving things around rather than having to write. It was very, very engaging, very enticing. And if they want to write, they can just do some scribbles, and maybe I'll give them some whiteboards and marker pens that they can write and then rub things out if they want to make some quick jottings. But it means that they can do mathematics without having to feel the slog of having to write. And for a change, that not to do it every time, you do want some written evidence that they've done some work, but they really, really enjoy that way of having to think. You can make these puzzles harder, so I made them a little bit harder by putting in 2 question marks. In the Follow Me cards, I accidentally made it harder by having a mistake in it. Oh yes, I promised I would show you how to fix that. But you can make them harder, for example, by having 2 questions with the same answer. So you have to use some logic to figure out which number 4 matches, because the other ones have to then fit. You can make them easier. So one of my colleagues, you can make this puzzle easier by just not putting anything around the edges. So there are no false answers or questions. One colleague I saw, I think I'm almost at time. 2 minutes?
No, keep going. If Pavnita Aurora could come up and set up while you're in.
Oh, yeah, with pleasure. So one of my colleagues around the edges, instead of putting false questions and misleading things, they put a letter on each edge, and when they'd finished the puzzle, the letters around the edge spelt out something relevant to the puzzle. So if it was Pythagoras, it was something like hypotenuse square or something. So the edges spelled out something of interest. So there are lots of ways, and students really, really do enjoy it as a change of things.
Can you plug yourself back?
Oh yes, I can plug myself back in, yes.
Just show the editing that you were doing.
Oh yes. Does it come up, or if I... Yes, it's come up. So the editing I was going to do. So here's the dominoes card. So you can see this time, instead of saying cards, it says pairs, because they are pairs. And the second one was who has 5 plus 2 times 7, which is 19, not 21. The answer is I have 21, should be I have 19. That's it. And then if I run that through Jigsaw generate, puzzle follow me, wait a few seconds for Lua LaTeX to run. I think I'm using Lua at the moment. So a few things I'd like to configure, for example, is which TeX engine do you want to use, and so forth. And now I'll have a whole bunch of results, and puzzle follow me. So now the puzzle will... There's the puzzle follow me activity, page 1 of 1, and somewhere there'll be now an I have 19. There we are, down here, I have 19. It was I have 21. And if you want to see the answer, if you look at the solution, there you have the solution. I have 18. Who has 18 minus 9 divided by 3? I have 15. And there you have it. Okay, thank you very, very much for your time.
Thank you.